everyone. So today we're going to be looking at solving some absolute value equations. And then for homework tonight, I'm going to have you try 6 practice problems. So remember that the absolute value of a number is the distance away the number is from 0 on a number line. So if I gave you just a really simple absolute value equation here, we want to know what values of x are going to make this statement true. The absolute value of what is going to give me a positive 2. And for this, there are actually 2 possible solutions. One of them would be x equals 2. And that's because if I substitute in the absolute value of 2, when I take the absolute value, I get a 2. But I can also substitute in a negative 2 because if I put in absolute value of negative 2 and simplify that, I also get 2 equals 2. And if I plot those x values on my number line here, negative 2 and positive 2, they are the same distance away from 0. So that's what the absolute value means. These values are both 2 units away from 0. So keep this in mind as we're kind of going through and doing these problems, because remember that there could be multiple solutions here that would make an absolute value equation true. And to solve an absolute value equation, we're going to be looking at them in the form of this absolute value of ax plus b. A and b are just numbers, and that's going to be equal to c. And c has always got to be greater than 0. And we'll look at a problem that kind of shows that in a couple minutes. So when we're solving our absolute value equations, so that we kind of get the idea of what we were talking about up here with 2 possible solutions, we're actually going to be rewriting the function itself without the absolute value bars, one as an ax plus b equal to whatever this number is on the outside of the absolute value. But our second equation is going to be this ax plus b stuff is equal to the opposite of what's on the outside, again, to kind of capture both possible solutions here. So one equivalent form here, if I split up, again, I'm going to have 2 equations here that I'm working with. For this absolute value of x plus 5 equal to 8, one of my equivalent equations is going to be x plus 5 equal to 8. And if I solve that, subtract 5 from both sides, my first solution would be x equals 3. My second equivalent form would be to take the x plus 5, and again, whatever's on the inside of the absolute value is going to stay the same. I'm not changing any signs of this. But instead of equaling it to a positive 8 like it did up here, it's actually going to be equal to a negative 8. And that, again, captures both of my solutions here. So if I take this and I subtract 5 from both sides in this equation, I get an x value of negative 13. So do these both work, I guess, is the question. When we are solving these absolute value equations, we always want to go back and check our work. So we want to make sure that this is a solution by substituting it back into the original equation. Same thing here. Take this negative 13, substitute back into the original equation. So if I do that quickly, let's see, 3 plus 5 and the absolute value is equal to 8. That's going to be the absolute value of 8 is equal to 8. That does give me a true statement. So that means that one of the solutions here is definitely x equals 3. If I do the same thing for this negative 13, and the absolute value, negative 13 plus 5 equals 8. It's going to give me a negative 8 on the inside of the absolute value bars, which does give me 8 equal to 8. So that means that this does work as a solution as well. So we'll do kind of the same thing in example 1 and example 2 down below. We're deciding just whether this number, in example 1, x equals 1, we want to know if x equals 1 is a solution to the equation. So in order to do that, we'll do pretty much what we did over here. We're going to substitute it in for our x on the inside of the absolute value, and we're just going to check. So I get absolute value of 11 minus 4 times 1 on the inside of the absolute value bars equal to 7. Again, I'm not solving here. I'm just going to simplify all the way down. So on the inside, 11 minus 4, that's going to give me the absolute value of 7 is equal to 7, and that does give us a true statement. 7 is equal to 7. So that means x equals 1 is a solution. So if we do that with our second problem here, we're looking to take this absolute value of 3x plus 8 equal to 20. We want to know if x equals -4 is a solution. Substitute it in here. So 3 times -4 plus 8 equals 20. That gives me -12 plus 8 on the inside here. That's going to give me a -4. Absolute value of -4 is +4, and this gives me a statement that says 4 is equal to 20. Obviously not. So when that happens, when you end up getting an untrue statement, that just means x equals -4 is not a solution. So there may be combinations of, like in the problems that we're going to solve, there may be some that you get a solution that does work. There may be some that you get a solution that doesn't work. Maybe none of the solutions work, and maybe all of the solutions work. So it just kind of depends on the problem that you're given and the x values that you end up getting at the end. So let's take a look at some examples here on the next page. So to start the solving process, the first thing that we need to make sure is happening is that the absolute value expression is isolated first, meaning that the absolute value bars are by themselves on one side of the equal sign. So in this case, I don't have anything added or subtracted before or after the absolute value bar, so I can go straight to splitting this up into my two equations. So my first equation is going to be 11 plus 2x is equal to, again, +5, not changing anything on the signs on the inside here. My second equation setup is going to be 11 plus 2x is equal to -5. And then from there, I'm just looking to solve for x. So if I subtract 11 here, I get 2x is equal to -6. Divide by 2, I get an x value of -3. Same thing over here. Subtract 11 from both sides. That should give me 2x is equal to -16. Divide by 2, I get an x value of -8. And again, I'm not just going to kind of take this as being like, oh, look, there are my two solutions. I'm done. I'm going to go ahead and I'm going to check. So my check is going to be to take this x value, and I'm going to go back up to my original function, plug that in. 11 plus 2 times -3 is equal to 5. That gives me 11 minus 6 on the inside there, which should give me the absolute value of 5 equals 5, which should tell me that 5 is equal to 5, so -3 is going to be a solution here. Do the same thing for the -8. 11 plus 2 times -8. That's going to give me 11 minus 16 on the inside of here. That's going to give me -5 on the inside of the absolute value bars, which should tell me 5 equals 5. So that should also work as a solution. And usually as I'm checking them, if it's a solution, I'll go ahead and either circle it or box it in to remind myself, like, checks out, that's a solution. Checks out, that's a solution. All right, let's look at example 4, a little bit different because this time I do have other things going on the outside of the absolute value bar. So the first thing that I want to do is I need to get rid of this to go to the other side before I can take my equations and split them. So first step here is going to be to undo that 7, and I'm going to get the absolute value of 1/2 x minus 3 is equal to -9. So on the front side, I specifically made a note saying that this value, the c value, should always be positive. So what happens when it is negative? Well, we're going to find out. So let's split our equations. 1/2 x minus 3 is equal to -9. And then my other equation, I'm going to take the opposite of -9. I'm going to put 1/2 x minus 3 equal to +9. I'm going to do the same thing I did over here, solve for x. So here, add 3. I get 1/2 x is equal to -6. And then I can either divide by 1/2 or I can multiply each side of this equation by 2 to undo that fraction. And I get x equals -12. Here, add 3. I get 1/2 x is equal to 12. And again, undo that 1/2 by multiplying by 2 on each side. This is going to give me x is equal to 24. So if I check here, I'm going to go back up to my original. So I'm going to plug in, let's see, 1/2 times negative 12 minus 3 plus 7 is equal to negative 2. That's going to give me, let's see, negative 6 minus 3 plus 7 equal to negative 2. Negative 9 plus 7 equal to negative 2, which tells me 9 plus 7 is equal to negative 2. Obviously, that is definitely not true, so that is not a solution here. If I try the 24, 1/2 times 24 minus 3 plus 7 equal to negative 2. That's going to give me 12 minus 3 plus 7 equal to negative 2. That's going to be positive 9 in there, which again still leaves me with 9 plus 7 is equal to negative 2. Obviously, again, not a true statement. So if neither of these check out, if I don't have either of these coming up as a solution here when I check it, this is actually a no solution. And I'll tell you why. C always has to be positive, because there's literally nothing that I'm ever going to be able to plug into an absolute value here and for it to equal a negative number. And that's kind of why my check didn't work. Anytime I tried plugging anything in over here, I always got a positive number over here, and I just happened to add 7 here, which was never going to equal a negative number. So no matter what I plug in here, it's never going to output a negative number. So even without doing any work, I can automatically say this is going to be a no solution, because there's nothing that I can put in here for x that would ever spit out something that's negative from an absolute value. So that's kind of like a little bit of an exception type of a problem, but it's kind of good to see it done out and why that doesn't work. Just instead of kind of solely basing your reasoning on just because C's got to be positive. So that's why that doesn't work. All right, we'll look at one more kind of different problem here, and then we'll look at some other types of examples. So there's a couple different ways that you can go about solving this one. If you wanted to take this whole quantity and add it to the other side, you could definitely do that. You could also subtract 2x from both sides first and then divide by -1 if you wanted to. So whichever way you feel more comfortable doing this, I guess I'll just subtract 2x. And again, the reason that I need to do this first is because the absolute value bars are not by themselves on this side of the equation. So if I get rid of that, I end up with negative times the absolute value of x plus 2 equal to, I'll write this as negative 2x plus 11. And then I'm going to want to divide by -1 here, because technically there's a -1 on the outside of the absolute value bars here. So I get absolute value of x plus 2 is equal to positive 2x and then minus 11. All right, so for this one ends up being a little bit different because I don't just have a constant on this side, I actually have a binomial. So what's going to end up happening is when we rewrite, the first one is just going to be x plus 2 is equal to 2x minus 11, which is pretty straightforward. But my other split is going to be x plus 2 is going to be the opposite of the entire expression, 2x minus 11. And what I mean by opposite of the entire is that I'm really taking a negative and I'm going to want to distribute it to both of these things once I'm kind of going ahead and solving that problem or solving that equation. So if I start over here, I'll move my x's to one side. So I'll subtract an x. I get 2 equals x minus 11. If I add 11 to both sides here, I get an x value of 13. We'll check this in a second. Over here, first step is going to be to distribute this negative on the inside here. So I get x plus 2 equals negative 2x plus 11. And then I will, again, collect all my x's on one side, subtract an x. That's going to give me 2 equals negative 3x plus 11. If I subtract 11 here, that's going to give me a negative 9 is equal to negative 3x. Divide by negative 3, I get an x value of 3. So then, again, I'm not done yet because I need to also check these. I'll do my check over here on the side. So my check, if I go back up to my original, I'll do 13 first. So 2 times 13 minus the absolute value of 13 plus 2 equals 11. That should give me 26 minus the absolute value of 15. So 26 minus 15 equals 11. And that should work. 11 equals 11. So x equals 13 is definitely part of the solution set here. And then I'm also going to want to check this 3. So 2 times 3 minus 3 plus 2 on the inside there. That's going to give me, let's see, 6 minus the absolute value of 5, which gives me 6 minus 5, which gives me 1 equals 11. So when this happens, when I have an x value that does work and an x value that does not work, usually I'll just make sure to, again, to either circle or box in the one that does work. And then I usually don't box this one in, but what happens is there's a special name for these types of problems that don't have solutions that work, and these are called extraneous solutions. So these are solutions that do not work when substituted into the original equation. So what we would say about this problem is that x equals 13 is a solution. X equals 3 is actually an extraneous solution. So x equals 3 is extraneous. So if you want to try example 6 on your own, you can go ahead and pause the video. I will talk through this one, so if you want to see this one done out afterwards and you want to hit play, you can go ahead and do that. So for this one ends up being pretty similar to example 5. I've got my absolute values over here by themselves, which is good. And then I have this binomial. So my first split is going to be 3x plus 2 equals 4x plus 5. My second split is going to be 3x plus 2, and that's going to be equal to the opposite of this 4x plus 5. So subtract 3x over here. That's going to give me 2 equals x plus 5. If I subtract 5, I get an x value of negative 3, and we'll check that in a second. Over here, distribute in my negative. 3x plus 2 is equal to negative 4x minus 5. I'll go ahead and add 4x to both sides over here. I get 7x plus 2 is equal to negative 5. Subtract 2, 7x is equal to negative 7. Divide by 7, x should be equal to negative 1. And then here's my check. Back up into the original. So absolute value of 3 times, let's see, we'll do negative 3 first. Negative 3 plus 2 equals 4 times negative 3 plus 5. That's going to tell me this is negative 9 plus 2 on the inside here, negative 12 plus 5 out here. That's going to give me 7. And this is actually going to give me negative 7. So when I take the absolute value here, I actually get 7 is equal to negative 7. So that is not true. That definitely means that negative 3 is an extraneous solution. But let's check negative 1. So 3 times negative 1 plus 2 equals 4 times negative 1 plus 5. That's negative 3 plus 2 on the inside there. That gives me negative 4 plus 5 here. Absolute value of negative 1 should be equal to 1. 1 equals 1. That is good. Oops, can't really see that there. So that means that x equals 1 is my solution for this problem. X equals negative 3. That is extraneous. All right, last problem here. Now this one's a little bit different because now I've got kind of this 7 hanging out front of my absolute value bars, which is fine. To undo that, I'm going to go ahead and divide it out. So I get the absolute value of 5x minus 2 should be equal to x plus 2, I believe. And now that my absolute value bars are by themselves over here, again, my split, 5x minus 2 is going to be equal to x plus 2. Over here, I'm going to get 5x minus 2 is going to be equal to the opposite of x plus 2. If I subtract x over here, I get 4x minus 2 equals 2. Add 2, I get 4x equals 4. First possible x value is a 1. Next, I'll go ahead and distribute that in. I get 5x minus 2 equals negative x minus 2. I'll add an x here. I get 6x minus 2 equals negative 2. If I add 2 over here, I get 6x equals 0. Divide by 6, I get x equals 0. So let's check these. So go back to my original. 7 times the absolute value of 5 times 1 minus 2 equals 7 times 1 plus 14. That's going to be 7 times 5 minus 2 equals 7 plus 14. So 7 times 3 equals 7 plus 14. And that should tell me that 21 equals 21. So that one should work. And then if I try my x equals 0, 7 times 5 times 0 minus 2 equals 7 times 0 plus 14. That's going to give me 7 multiplied by the absolute value of negative 2 equals 14. So 7 times positive 2 equals 14. 14 equals 14. That one should also work. So here I have two solutions that work, x equals 1 and x equals 0. All right, so now it's time for you guys to try some practice problems. Let me know if you have any questions.